So this one says triangle EFG is similar to triangle LMN, and we want to find the length of the two missing sides over here. Okay, so we know a lot of information. First of all, we can tell which sides correspond by looking at what it says. It says that EFG is similar to LMN. So for example, if I start with EF, those are the first two letters, they have to correspond to the first two letters. So EF corresponds to LM. I'm going to go ahead and find all of my corresponding parts first, and then I'll start answering the question. All right, so then I'm going to go to FG. Those are the last two letters. They have to correspond to the last two letters. So FG has to correspond to MN. And then lastly, the first and the last, so EG, has to correspond with the first and the last. Now we got lucky in this problem because the triangles haven't been rotated, so it's kind of obvious which side corresponds with which, but sometimes it's not so obvious, so make sure you go back to that similarity statement. Okay, so the only set of corresponding sides that we know both of the lengths is right here. And so we can use those two to find the scale factor. So to get from 4 to 2, I'm making it half of its size. So the scale factor is going to be 1/2 because 4 divided by 2 is 1/2. So if I want to go and find LM, then I just have to take 7 and find 1/2 of 7. So I'm going to take 7 and I'm going to multiply it by my scale factor, which was 1/2. So 7 times 1/2, or half of 7, would be 3.5. So the length of LM would be 3.5 units. Now I want to do the same thing for the other side. If I want to find LN, it corresponds to EG. The length of EG is 10 units. So I'm going to take 10 and I'm going to multiply it by my scale factor. In other words, I want to take half of 10, which is 5. So LN is going to be 5 units long.